Hey guys, my name's James Jones, and this is my lab 3 on a black hole. So in this lab, we wanted to analyze a star's motion and determine the net force acting on the star from the black hole for all points that we collected. And then we wanted to use this data to estimate the mass of the black hole. We assume that the net force on the star is due only to the gravitational force of the black hole. So for this lab, we used a form in Newton's second law known as the momentum principle. And as you can see, this says that the net force equals the change in momentum over the change in time. So we can find the net force at each point in this lab by dividing the star's momentum by the change in time between each data point. And then we could also split up the net force into parallel and perpendicular components using this formula, which calculates the rate of change of momentum in the magnitude and direction. So the parallel component tells us the rate of change in the magnitude of the force, as we can see right here, So the parallel component tells us the rate of change of the magnitude of the force, as we can see down here, and the perpendicular component tells us the rate of change of the direction of the force, as we can see here. So getting into our calculations, we use a program called GlowScript to create a computational model that analyzes the motion of the star around this black hole. And here we can see our initial conditions with the gravitational constant, the mass of the star, which was 2e30 kilograms, and the delta t, which was 1 day in seconds between each data point. And then here we can see where we use Newton's second law by calculating the change in momentum and using that to find dp dt. Or actually, no. And here we have our calculations continued, where we have the initial and final momentums, and we use that to calculate dp dt, which is the net force. And then over here, we separated our net force into our parallel and perpendicular components using Newton's second law and the formula we showed on the last slide. And then after we got the perpendicular and parallel components of the net force, we then used these to calculate the mass of the black hole, as you can see here, by rearranging the gravitation. Actually, let me how do I want to say this? Yeah. So then after we got the components for the parallel and perpendicular, actually no, how do I say this? So then after we got the parallel and perpendicular components of the net force, we used these to calculate the mass of the black hole at each point by using this formula you see here, which is simply just a rearrangement of the gravitation formula, solving for one of the masses. And then after we got the mass of the black hole at each point, we put it into a spreadsheet and got the average of all the points to get our estimate for the black hole. So, for our discussion, how is the net force and its parallel and perpendicular components different from the rate of change of momentum and its parallel and perpendicular components? Well, it comes down to the fact that we can find the rate of change of momentum specifically by observing the system's motion, and then we use these findings to calculate a net force. We can't actually see the net force in the observed motion, but simply the motion of the object, which gives us the change of momentum. And for our second question, it says to imagine a black hole whose mass you found was removed and a different black hole who is placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? In other words, is it possible for you to find a value for the mass of the new black hole that is different from the mass you found for the original one? And the answer to this question is no, you would not be able to find a different mass for the new black hole if the motion of the star remains unchanged. This is because if the star is only affected by the gravitational force of the black hole, if there was a new mass for the black hole, we would have a different gravitational force, which must change the motion of the star. So that would be my lab. Thank you and have a good day.